Hi, here we are for the video of March, in which I will be talking about the law of gravitation of Newton and also about the law of motion that he formulated. Okay, so let me put the slide and we start. Okay, so today the video will be about the law of gravity formulated by Newton. My name is Mariam.Cosmology Lopez. I'm a researcher at Ikerbasque and a lecturer at the University of the Basque Country in northern Spain. You can contact me through that email, mariam.muhmadi@gmail.com, and you can follow me on different social media like YouTube, Facebook, Instagram, Twitter, or TikTok at Mariam.Cosmology. Okay, so let's start with the talk of today, which is essentially related to gravity. At the end, if we want to understand the universe, how was it created, how does it expand, and so forth, we need to understand the interaction of gravity. Okay, so what is gravity? Before that, let me just formulate a few questions. One of them is, why do we fall after jumping? For example, that person in the picture, okay, is jumping, okay, and then we land somewhere. We land, I insist. So this means that there is something attracting that person toward the earth, and it's gravity. Another question, like on the slide at the beginning of the video, we see some dolphins that are jumping and then they go into the water. Why does this happen? Why did they go back to the water? Why did they not fly? Right? One more question. We can have fruits on trees, and those fruits, like an apple, they end up falling from the tree. Why do they reach the earth rather than fly into the sky? Why is this? So if we discover the reply to this question, we will be able to understand the planetary movement, because essentially we would understand how does gravity work, and that's the first step to our understanding the cosmos, the cosmology. Newton, as I wrote there, was crucial at this regard. Okay, so who was Newton? So Newton was an Englishman. He was born the 25th of December back in 1642 and passed away the 20th of March 1726. He lived over 80 years. He was, as I said, an Englishman, mathematician, physicist, and astronomer, among other things. Okay, so in mathematics, he was very important as he introduced calculus. There was another German mathematician who was also more or less at the same period that was also quite important for the calculus. Okay, Lewis. And then in physics, well, he was quite important, and he wrote a book published in 1687, Mathematical Principle of Natural Philosophy, which included two key concepts. One is related to the motion of the bodies, okay, the laws that describe the motion of bodies, and the other one is related to the gravitational attraction. Okay, so he formulated, I insist, the laws of motion, and also he discovered the law of gravitation, okay, which explain, for example, Kepler Laws that we described on the video of January. The laws of gravitation can also explain the tides, and it can also explain the precession of the equinox. So the Earth is essentially rotating respect to its own axis, but that axis itself is rotated, it's making some rotation. It takes a long time to complete a whole rotation of that. I mean, the rotation of the axis of the Earth take a lot of time, about 26,000 years, okay? The Earth around itself, as we know, 24 hours. So the laws of gravitation can explain also these, as I said, the tides and the precession of the equinox. And very, very important, the laws of Kepler. So what are first of all the laws of motion? So in that picture we see a man who is pushing a kid on his bicycle. Okay. So the laws of motion, what essentially said is the following. The force that is exerted over a body is equal to the mass of that body times the acceleration. And what is the acceleration? So the acceleration of an object is essentially how does the velocity of that object change over time. So that very important law that was provided by Newton. So this means that if there is no net force acting on a body, we have two options. Either the body is at rest, it's not moving, or then if the body is moving, he's doing it at a speed which is constant. Okay. Then we have also what is known as the action-reaction law, which is essentially said if, for example, I'm exerting a certain force, my right hand is exerting a force over the left hand, then my left hand is exerting the same force modulus, although in the opposite direction to my right hand. Okay, so this is the action-reaction. And then we have the universal law of gravity, which is very important, and again formulated by Newton. So what he discovered is that if we have two massive bodies, then there is an attractive force acting between them, okay? And that force is stronger the heavier or the more massive are the objects, and weaker the further apart are the objects, okay? In fact, the force is inversely proportional to the square of the distance between the body and proportional to the product of the mass of the two bodies. Now, if we combine the law of motion from one hand and the laws of gravitation from the other side, we end up with what we formulated on the previous video in January, which are known as Kepler Laws, which essentially describe the motion of the planet around the star and also of a planetary system, for example, the solar system, around the center of our galaxy, the Milky Way. So this is essentially what is stated, is what is represented on this figure. We have a planet, the blue one, which is making an elliptical orbit around the star, in this case, for example, the Earth and the Sun. And we have what is known as Kepler law, in particular, the third Kepler law. What states is that if we know how long does the planet take to make this whole orbit, okay, time, unit of time, I mean, and we know the average distance from the planet to the sun or the star, then we can deduce, and this is what is new, by using Newton gravitational law, we can deduce essentially the mass of the object at the center. For example, the mass of the star, the sun, or for example, the mass of what is at the center of our galaxy, Sagittarius A star, that we spoke about on the day, the video that was commemorating the Day of the Woman and the girls in science. Okay. As I said, well, what I'm explaining here for a planet orbiting around the star applies to the whole solar system orbiting around the center of our galaxy. And in fact, it was this what Guess, who she won the Nobel Prize of last year with two further colleagues. Well, what she did with her team was essentially to measure the rotation of some stars very close to the center of our galaxy. The center of our galaxy is located Sagittarius A star, and what they measure was the complete orbit of some star very close to Sagittarius A star, in particular the star S2, by measuring the full orbit, elliptical orbits of S2 around Sagittarius A star, and by knowing how far is S2 from Sagittarius A star, essentially they could deduce the mass of Sagittarius A star, and therefore they could conclude that it was a supermassive black hole. Okay, it was too massive to be any other object. So Newton's law was discovered back in 16-something, in the 17th century, and that discovery was used 300 years, roughly, a bit more than 300 years, for the measurement that deserved the Nobel Prize of 2020. Why I'm saying this, sometimes we should be patient with science. Sometimes people say, okay, but this what is, why do we do science, or why is it so worth it doing science? But sometimes the answer takes a long long time as this example. Well, this is essentially what I wanted to transmit on this video. We will be back in March. So please, if you like the video, put a like on YouTube, and you can follow me also on the different social media that I showed before. Okay, and for now, that's all. Bye, and see you in March.